Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1157, indicates an issue with the AF sensor, specifically the sensor 1 AFS circuit experiencing high voltage. In this context, AF refers to the air-fuel mixture detected by the sensor, which plays a critical role in optimizing fuel efficiency and emissions control in your vehicle. The AF sensor, part of the Powertrain Control Module, PGM-FI system, is located upstream in the exhaust system, typically positioned before the catalytic converter. A malfunction in this sensor could lead to significant performance issues and increased emissions, impacting the overall functionality of the Honda CRV. Before proceeding with troubleshooting, it is crucial to document freeze data and any onboard snapshots, as they provide essential information concerning the vehicle's state before the DTC was triggered. DTC P1157 is related to the AF sensor, which is vital for monitoring the air-fuel ratio in the combustion process. This sensor sends real-time data to the engine's Powertrain Control Module, PCM, which adjusts the fuel delivery accordingly to maintain optimal performance and reduce emissions. The AF sensor is typically situated just before the catalytic converter in the exhaust system of the Honda CRV, making it a critical component for both performance and compliance with emission standards. If this sensor detects high voltage, it signals that either the wiring or the sensor itself may be faulty. Therefore, understanding its location and function is key to accurately diagnosing the problem. Several factors can trigger DTC P1157, primarily a malfunctioning A-factor sensor. When this sensor is defective, it can send erroneous voltage readings to the PCM, causing high voltage indicators. Another common cause is an open circuit in the wiring associated with the sensor. If there's a break in the wire, the signal can be disrupted, leading to erroneous readings. Additionally, poor connections at the sensor or within the PCM can contribute to high voltage issues. It's essential to conduct a thorough visual and physical inspection of the wiring and connections during the diagnostic process to rule out these potential causes. The symptoms associated with DTC P1157 can significantly affect your driving experience. First and foremost, the check engine light will likely be illuminated, indicating an issue that requires attention. Furthermore, you may experience a noticeable decline in fuel efficiency, as the engine may not be operating optimally due to inaccurate air-fuel mixture readings. Rough engine performance, including misfires or stalling, can also manifest, creating a driving experience that is inconsistent and potentially unsafe. These symptoms, if left unchecked, could lead to further mechanical issues, emphasizing the importance of addressing the DTC promptly. The first step in troubleshooting DTC P1157 involves proper verification of the issue. Start by turning the ignition switch to the on position, without starting the engine. This prepares the vehicle's systems for diagnostics. Then, use the Honda Diagnostic System, HDS, to clear any DTCs currently stored in the PCM. Following that, start the engine and allow it to idle for 1 minute to stabilize the readings. Finally, check the HDS for any pending or confirmed DTCs. If DTC P1157 is indicated, it confirms that the failure is persistent. Thus, you should proceed to the next troubleshooting steps. Conversely, if no DTCs are shown, it may indicate an intermittent failure, prompting a check of the sensor's connections. The second step entails checking for an open wire in the AFS Plus line, crucial for the AF sensor's signal transmission. Begin by turning the ignition switch to the lock position. 0. Next, utilize the HDS to jump the SCS, Service Check Signal, line, preparing the vehicle for further testing. Carefully disconnect the AF sensor, Sensor 1, 4P connector, and the PCM's connector C, 49P. With both connectors removed, you will check for continuity between the designated points to ensure that the AFS Plus wire is intact and transmitting signals properly. Establishing continuity is essential. If continuity is detected, the AFS Plus wire is functioning correctly, and you can move on to the next step. At this stage, you will carry out a similar procedure to check for an open wire in the AFS line. Keeping the ignition switch in the lock position and the AF sensor, Sensor 1, 4P connector, and PCM connector C, 49P, disconnected, you will again test for continuity. This time, focus on the AFS wire, which is crucial for the sensor's negative feedback. By checking continuity between the specified test points in the PCM connector, you can establish whether the AFS wire is functioning properly. If continuity is not found, it indicates an open circuit, and you will need to repair the break in the wire connecting the PCM to the AFS sensor before performing further diagnostics. This troubleshooting step involves substituting a known good AF sensor for a more definitive diagnosis. First, replace the AF sensor, Sensor 1, with one that you know to be functioning correctly. Then secure all connectors. Next, turn the ignition switch to the on position, 2, to power the system without starting the engine. Reset the PCM using the HDS to clear any previous settings and begin fresh diagnostics. Perform the PCM idle learn procedure to recalibrate the engine's idle behavior according to the new sensor. Lastly, check for any pending or confirmed DTCs with the HDS again. If DTC P1157 is still indicated, it suggests either an issue with the current sensor or requires an update or substitution of the PCM itself. The final step involves a thorough verification of all repairs made to resolve the issue outlined by DTC P1157. Begin by turning the ignition switch to the lock position and make sure that all connectors are properly reconnected to their respective harnesses. Then turn the ignition switch back to the on position, 2. It is essential to reset the PCM again using the HDS and perform the idle learn procedure to ensure that the system adapts to any changes made. Finally, check for any pending or confirmed DTCs with the HDS. If DTC P1157 reappears, it may indicate a need for further investigation of the connections or components. Conversely, if no DTCs are indicated and the system operates as expected, the troubleshooting procedure can be deemed complete. Preventive maintenance is crucial in avoiding recurrence of DTC P1157 and ensuring the reliable operation of your Honda CRVs engine management systems. Schedule regular inspections of the AF sensor for any signs of wear or damage. This can significantly reduce the chances of future failures. Also, ensure that all associated wiring remains intact and free from corrosion or damage. Regularly clearing DTCs during routine service checks can help maintain the health and performance of the vehicle's electronics. By fostering a proactive maintenance schedule, you can extend the life of your sensors and enhance the efficiency of your vehicle. In conclusion, diagnosing DTC P1157 requires a systematic approach, focusing on both the AF sensor and its associated wiring. Early identification of symptoms, such as a check engine light or poor fuel efficiency, can lead to timely and effective repairs. Following the outlined troubleshooting steps ensures that no hidden issues remain and confirms the integrity of the system. Additionally, regular preventive maintenance plays an essential role in avoiding future occurrences of such diagnostic trouble codes. By establishing a routine checkup, you can maintain ideal performance levels and uphold the longevity of your Honda CRV. Please like and subscribe to the channel. See you next time.